Dear students, today I am going to discuss on thread. Before giving an idea on thread, let's see what's the process means. Process means it's a program executions. It's a program execution which is managed by operating systems. So as the name thread indicates that, say for example, you have seen the rope. In the rope there are multiple fibers will be there. Every fiber plays its own role. In a rope, say that by some means one thread breaks, the other thread will try to take care of. That means if these things is put together, if this is being put together, then it becomes a process. Whereas individual components is a thread. Both perform the similar task, but the difference is that it has with respect to the size of the task, they are differentiated. So I can put that thread is within the same process. So it performs the task. Which type of task? It performs the task. Task means it performs instructions with the given data. So that's the task or the process. Now thread is, we can say a thread, it performs small task, whereas process, it performs heavy weight or heavy duty task. Both carries out the task, but here if you try to see, it performs the small task, whereas this performs the heavy task. That's the difference. Thread is normally represented. Thread is normally, it presented in a software approach. This is the thread. However, it's a software approach. And usage, if we use the thread, what happens? It improves the performance of operating systems. That you keep in your mind, that it improves the performance of the operating systems. Now when we say a thread, so if I say a thread is nothing but we write a process code, and this process code, once it is executable, then that particular code satisfies the conditions of the thread. That you keep it in your mind. Now let's see the representation of thread. So how we represent the thread in a block-wise representation. So if you want to represent the thread can be represented in a simple way. It is easy to remember. What you do, you draw a block and divide that block into 3 partitions. One partition here, another partition here, this way. So in these partitions, what you do is that you divide 3 blocks. One block here, another block here, another block here, 3 here, 2 block here. Then you create another block here with a certain set of lines. This is easy way to represent the thread. A thread which is represent in such a form, this is known as a single thread. A single thread, when I say this particular word, that means there is a single process with a single thread. So the process, there will be a single process. Single process. Now here, what are these individual components is being represented? I put for an easy way to represent is that you denote this one as R, this one as C, and this one is S, and this one as D, and this one is F, and this is code. That means the thread, it consists of the components like R. R stands for register. And what is the duty of the register is that the register, inside the register, you hold all the variables because it's a data. So you have to hold all the working variable. It hold working variable. That is what in the register, as you are knowing. The second is C is nothing but we call it as a program counter. Program counter. Now what is the program counter responsibility? The program counter responsibility is to track the instructions. Okay. Now the S stands for stack. Stack is something like when you go to the library, you see a collection of a book. So like this is known as stack. Stack is basically used to check the execution history. Whatever, how many processes being executed, all this information is being monitored by the stack. Just like how you see this particular thread, the same thread we can further represent in another forms in a multiple thread way. So in the multiple thread, if you want to represent the same thread, what you have to do is that it is a very simple. Only the thing is that you have to do a partition. Let us take a process with a single process, but the single process is having a multiple thread. Let us take it is having a 3 thread. So here also the same way is that we divide the partitions, 3 partitions. But here one thing is that we have to make a partitions like this, since it is a 3 thread, and here also same way, first thread, second thread, and inside this one, instead of preparing in a horizontal way, you put a 3 blocks in a vertical way, 3 blocks, 1 2 3, 1 2 3, and here it remains the same things, but here we have to put like this. That is a common code. So this is we can put this one as a code which is common for first thread, second thread, third thread. And what is this particular thing? This is represented as R, and this is C, and this is that is we seen that register, counter, and stack, and this is data, and this is file. So that is how we represent. And such type of thread is basically for a single process, or you can say a multiple thread. Okay. There is one important point I need to discuss here, that is the process and thread difference. So let me put the heading under this one is that the difference between process and thread. Now, as the name indicate, I have told you process is a program executions for a given task. So the complete task is being executed, but how, the same task but in a smaller level or lighter, a smaller load, the particular thread is also executing, but that thread, when it process, it carries out a one-to-one thread interactions. So if I put it in a very simple way to understand the process versus thread difference, let me put the difference like this. In the case of a process, the process perform the heavy weight task, just remember, and what here is the thread performs the light weight task. That is one. Second part is that in a process, suppose you are running a process P1 and you want to switch over to P2. Every time switching over from P1 to P2, it need to follow the